Namaste students. In our last lecture we have learned about slope of a line. In today's lecture we'll learn how to form equation of a line under given conditions. Under this heading, first one are horizontal and vertical lines. Horizontal lines and vertical lines. Firstly, horizontal lines. If I say draw a line L at a distance A from x-axis, then what will you do? In this graph, if particular distance is given to you, let L be a line at a distance A means any fixed distance, A from x-axis. For example, if I say draw a line at a distance of 3 units from x-axis, that means what you can do? You can draw a line here. This line is at a distance of 3 units from x-axis. Same way, if I draw a line here, this line is also at a distance of 3 units from x-axis. That means, now if I am taking it as a A, means any value can be there. So, value of A can be positive or negative. When we are saying distance we always take in positive form. Distance will be A unit, but the values can be plus and minus both. Therefore, if we write y is equal to A or y equals to minus A, these both lines are horizontal lines at a distance of A unit from x-axis. That means equation for horizontal line can be y equals to plus minus A. Same way for vertical lines. In case we talk about vertical lines, vertical lines will be saying, suppose we want to draw another line, say L1. Let L1 be a line at a distance B unit from y-axis. In this case, suppose this is B distance, and we can draw a line here. This line L1 is at a distance of B unit from y-axis. Same way we can draw a line here also, which is also at a distance of B from y-axis, but here values will be positive and this side values will be negative. That means in case of vertical lines, equation of lines will be x equals to B or x equals to minus B. That means x plus minus B is the equation of vertical lines, or we can say line parallel to y-axis. Second one is point slope form. Suppose we have been given a line L having a fixed point P on it and slope of the line is also given. In this case, if we have to form the equation of a line, then Let us take one more point Q on it, having coordinates x2 and y. Then according to the formula of slope, how do we find slope? Slope is y2 minus y1 upon x2 minus x1. This you have learned in your previous lectures. If we shift this to this side, we will be having m into x2 minus x1 is equal to y2 minus y1. So, using this formula, we can find the equation of a line where fixed point of the line is given and slope of the line is given. After point slope form, let us study about 2-point form. Suppose a line L is given to us, which is passing through two given points, P having coordinates x1, y1 and Q having coordinates x2 and y2. I have taken this line L. In order to form the equation, let us take one more point R having coordinates x and y on it. As you can see that point P, Q and R are collinear points as they are lying on the same line. For collinear points, we know that the slope between PQ will be same as slope between PR, slope between RQ. So using this slope formula, we can form the equation of the line, writing that slope of PQ is same as slope of PR. How to form slope, how to find slope when 2 points are given? y2 minus y1 upon x2 minus x1. So slope of PQ will be y2 minus y1 upon x2 minus x1. And slope in case of PR, y minus y1 upon x minus x1. We can shift this x minus x1 this side. So we'll be getting equation in case of line when 2 points are given to us. It can be written as so this will be the equation for 2-point form. Next one is slope intercept form. This form is used when a line with a slope m and intercept is given to us. Suppose we take a point at a distance of C unit from origin. Then this point will be having coordinates as 0C. Then this distance is called y-intercept. A line L is passing through this point. Line L is passing through this point having coordinates 0 and C, and line is having slope as m. Then if we have to form the equation of the line, what is given? Point is given, slope is given. That means point slope form will be used. And under point slope form, we have learned that the equation can be written as y2 minus y1 equals to m into x2 minus x1. Let us take one point, suppose P, having coordinates x and y. This point is lying on the line. Then if we write the equation, this will be called x1 y1 and this is x2 y2. When we write point slope form, y2 minus y1 equals to m x2 minus x1. In place of y2, y will come. In place of y1, c will come. M in place of x2, x will come. In place of x1, 0 will come. Simply inserted the values in point slope form. Simplifying, y equals to mx plus c. So this equation is called slope-intercept form. Now in place of y-intercept, if x-intercept is given, that means we are given that line L is passing through a point D0 and P is any other point having coordinates x and y on the line. Then this point slope form will get converted into, this is x2 y2, this is x1 y1. So y2 minus y1 will become y minus 0 is equal to m x2. x2 is x and x1 is d. So x minus d. So in that case, equation will be y equals to m x minus d. This is the case if x-intercept is given. This is intercept form. Means here slope is not given, only intercepts are given. Suppose we have a line L having x-intercept as well as y-intercept. That means this line L is passing through 2 points A0 and 0B. This line is passing through 2 points. This point is at a distance of A unit from origin and this point is at B unit from this origin. That means ultimately what we have got? We have got 2-point form. Suppose we take any other point P having x and y on the same line. Then using 2-point form, this will be x2 y2, this will be x1 y1. So inserting the values in 2-point form, y will remain y only. Instead of y1, what will come? 0 will come. So we'll be writing y minus y1, y1 is 0, equals to y2 minus y1, that is b minus 0 upon x2 minus x1, 0 minus a, then x minus x1, x1 is a. So we are having y is equal to b on minus a, x minus a. This a will come here, so we'll be having minus ya equals to, opening the bracket, bx minus ba. Now shifting this minus b to this side, we'll be having ba minus ya equals to bx. Taking a common, we are having b minus y equals to bx. Now if we interchange the value of b and a, means if we take a to this side and b to this side, we'll be having b upon b minus y upon b is equal to x upon a. What we have done? We have taken b to this side and a to this side. And now if we shift minus by to this side, we'll be having x upon a plus y upon b equals to, b upon b means 1. So this is called intercept form. Form will be doing normal form. Normal means perpendicular. Let us take a line L. Now from the origin, perpendicular is drawn on this line. Perpendicular OA is drawn on this line L. Suppose this perpendicular distance is P unit. So as we know that line L and OA are perpendicular to each other, and when we were studying slope for perpendicular lines, we have learnt that for two perpendicular lines, relation is m2 equals to minus 1 upon m1. That means slope of line L is equal to minus 1 upon slope of OA. Suppose this line OA is making an angle of inclination theta with positive x-axis. So slope will be tan theta. Tan theta means sine upon cos. So we'll be getting minus cos theta upon sin theta. So what we are having here, for line L, we are having slope L, and this line is passing through the point A. So if we calculate the coordinates of this point A using point slope form, we'll be able to write down normal form. So let us find out what are the coordinates of this point. Suppose we draw one perpendicular here. So if we calculate this value OM and value AM, we'll be able to find coordinates of A. OM upon OA. Base upon hypotenuse is cos theta. Now OA is P. So we'll be getting the value of OM as P cos theta. AM, perpendicular upon hypotenuse, AM upon OA equals to sin theta. Again OA is P, so AM will come out to be P sin theta. Means we have obtained the coordinates of point A as P cos theta, this much distance, value of x, and this will be the value of y, and P sin theta. So we have obtained a line L with slope minus cos theta upon sin theta, and point A having coordinates P cos theta and P sin theta. So now using point slope form, y minus y1, this is next one y1. In place of y1, P sin theta will come equals to m. M means slope, and slope we are having minus cos theta upon sin theta into x minus x1. Instead of this y2 and x2 points, we can mark a point having coordinates x and y. So we'll be having y minus p sin theta and x minus p cos theta. Shifting this side, this side, p sin theta p sin square theta minus x cos theta plus p cos square theta. Shifting this p sin square theta to this side, we'll be having y sin theta is equal to minus x cos theta plus, now this p cos square theta plus p sin square theta. Cos square theta plus sin square theta is 1. So we'll be left with p only. Shifting this to this side, we'll be having p equals to y sin theta plus x cos theta. So this is normal form, where P is the perpendicular distance of the line L from the origin. How many equations of a line we have learned in this lecture? Let us recall. We have learned about horizontal line and vertical line. We have learned about point slope form. Means in case of a line, if point from which the line is passing and slope of the line is given, then we can use this formula. In case line is passing through two given points, then 2-point form, y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1 can be used. We have learned slope intercept form. Means when slope and intercept of the line is given, then we are using the formula m equals to mx plus c in case y-intercept is given. In case x-intercept is given, then y equals to m multiplied by x minus t. We have learned about intercept form, x upon a plus y upon b equals to 1. We have also learned about normal form, p equals to x cos theta plus y cos theta.